Okay, Assalamualaikum warahmatullahi wabarakatuh. Today, we're gonna present our material about sedimentation. The member of group is me, Acbellita Ayu Z NPM 44.
My name is Amanda Prastiwi. My number student is 46.
So my name is Rizal Bachtiar M. My NPM is 40.
And my name is Salsabila Prawardani, NPM 48.
Okay, so now I will explain the sedimentation process from general aspect. The first is definition of sedimentation. So sedimentation is a solid liquid separation using gravity precipitation to suspend solid. In general, sedimentation is used in drinking water treatment, wastewater treatment, and it advances wastewater treatment. So as we know from the picture below, the particles are suspended in the water. So by after time, the particles are settled on the bottom. Okay, next. Okay, so now I will explain the sedimentation types or sedimentation basin. The sedimentation types are generally constructed of reinforced concrete with a circle, square, or rectangular shape. There are three types of sedimentation types commonly used as seen in the image on the side. So the highest in the picture is horizontal flow type. The middle of the picture is radial flow type, and the lowest of the picture are upward flow type. Okay, next.
Okay, next we will talk about the sedimentation tool specification. You can see in the figure 5439, this is a wastewater treatment plant with circular primary and secondary sedimentation basins. Almost all processing plants use mechanically cleaned sedimentation baths with a standard circular or rectangular design. In primary sedimentation is used as a first step in advanced wastewater treatment. Primary sedimentation tanks designed and operated efficiently should dispose of 50 to 70% suspended solids and from 25 to 40% BOD. Sedimentation tanks have also been used as rainwater retaining tanks designed to provide a medium period of detention, 10 to 30 minutes for overflow from combined showers or rainwater showers. Okay, typical design and dimensional information for rectangular and circular sedi tanks used for primary processing is presented in this tabel. For the left tabel, this is a typical design information for primary sedimentation tanks, followed by secondary treatment and primary settling with waste activated sludge return, include detention time, overflow rate, and wear loading. And then for the right table, this is a typical dimensional data for rectangular and circular sedimentation tanks used for primary treatment of wastewater, include depth, length, width, flight speed, diameter, bottom slope, and flight speed. Next. These are rectangular tanks that use chain and flight type collectors are shown in figure 5 for 40. Equipment for the removal of settled solids generally consists of a pair of endless conveyor chains made of alloy steel, cast iron, or thermoplastic affixed to the chain at intervals of approximately 3 meters or 10 feet, made of wood or fiberglass. Inducting hose can provide good distribution across tank widths if speed is maintained in the range of 3 to 9 millimeter per minute. Inbound sealing is effective in reducing high initial speed and distributing flow to the widest possible cross-sectional area. If a full width seal is used, it should be extended from 150 mm below the surface to 300 mm. In circular tank radial flow pattern as opposed to horizontal in rectangular tank, to achieve the radial flow pattern, the waste to be set can be inserted in the center of around the edge of the tank, as shown in figure 541. Wastewater is transported to the center of the tank in a pipe suspended from the bridge or wrapped in concrete under the tank floor. In the center of the tank, wastewater enters a circular well designed to distribute the flow evenly in all directions. You can see in figure 5-42. The middle well has a diameter usually between 15 and 20% of the total tank diameter, and depth range from 2.5 meter or 3 to 8 feet, and must have a tangential energy busting index in the feed well. The energy busting device you can see in figure 5-43 serve to gather influence from the middle column and remove it tangentially to the top 0.5 to 0.7 meter from the feed well. The dump port is sized to produce a speed of 1.75 meter per second at maximum flow and 0.30 to 0.45 meter per second at average flow. Feed well should be sized so that the maximum speed down does not exceed 0.75 meter per second. The depth of the feed well should be extended about 1 meter below the energy busting inlet port. And then circular tanks 3.6 to 9 meter or 12 to 30 feet in diameter have solid removal equipment supported on beams, tractor, or duct center that supports the mechanism and is reached by footpath or a bridge. Typically, primary sedimentation tanks are designed to accommodate 15 to 25 hours of detention batch on the average rate of wastewater flow. Okay, next, Elsa.
Okay, next is process of sedimentation. The purpose of primary care, primary sedimentation, or primary clarification is to eliminate organic solid and floating solid. Typically, its primary clarification unit can be expected to remove 90 to 95% of settled solid, 40 to 60% TSS, and 25 to 35% BOD. Sedimentation can be used to coat the plant to remove precipitate and floatable solid. It is used in primary care, secondary care, and advanced wastewater treatment. In primary sedimentation, wastewater enter the tank or basin that settle. The speed is reduced to above 1 feet per minute. Heavier solid from water settle to the bottom, while solid that are lighter than water float upward. Settled solid are removed as solid and floating solid are removed as garbage. Wastewater leaves the sedimentation tank about the wastness and goes to the next step in treatment. Contaminant time, temperature, tank design, and equipment condition control process efficiency. Source from Spellman Frank R. Handbook of Water and Wastewater Treatment Plant Operation. Next is the video about process of sediment.
Okay, so now I will explain sedimentation process from its characteristic. So both table on the screen are types of wastewater characteristic or pollutant characteristic and its removal efficiency. From the left side, we know the first table is from design standard for municipal wastewater treatment plants by Japan Sewage Work Association Sedimentation. So the sedimentation tank could remove 30 to 50 BOD pollutant and 40 to 60% as settlement SS pollutant and 30 to 50% COD pollutant. So the from the right side is from Introduction to Wastewater Treatment book by Dr. Michael R. This table show us more details information. It divided by criteria. There are space, overflow rate, detention time, SS removal percent, such percent, and its application. From the horizontal, radial, and upflow has different characteristic of removal efficiency. From if we see in the SS removal, we know from horizontal types of basin of sedimentation basin can remove 40 to 50% SS, and from radial can remove 50 to 75%, and from upflow type can remove about 65%. And from the space, we also know the horizontal and upflow can be applied in a low space, but radial type just can apply in the high space. And we can see about the other information at this table. Okay, thank you. Next.
Okay, for the advantage and disadvantage of sedimentation, we take from three types of sedimentation types. The first one is horizontal flow type. Second one is radial flow type, and third one is vertical flow type. First, the horizontal flow type sedimentation tank. The advantage is one, the precipitation area increase, high sedimentation efficiency, and large water production. And this horizontal flow type have good hydraulic condition. But the disadvantage, one, due to the short residence time, its buffering capacity is poor. Two, high requirement for coagulation. Three, maintenance and management is difficult, and the sloping plate or tap needs to be replaced after a period of use. The second one is radial flow type sedimentation tank. The advantage is use mechanical mud discharge, which has better operation and simple management, and the mud discharge equipment has been shaped. But the disadvantage, the mechanical mud discharge equipment is complex and requires high construction quality. The third one is vertical flow type sedimentation tank. The advantage is the vertical flow sedimentation tank has a good effect, and the floor space is small, and the mud discharge is easy. So the disadvantage is the depth of the pool is large, construction is difficult, and the cost is high. It is commonly used in small sewage treatment plants with a water volume of less than 20,000 meter cubic per seconds. Operation and treatment. The operation and treatment of sedimentation basically from SNE 6775 2008 about procedure for operation and maintenance of EPA package unit. The important point and observation to make during an inspection are the discharge valves should be functional and oily. The tank floor should be regularly cleaned. The turbidity of water in the outlet should be 70 until 90% lower than the turbidity of raw water. And the operation of sedimentation body system. 1. Check the function of valves and the lid of the drain pipe. 2. Flow water from the slow stir to the faster body. Clean the foam or floating materials. Check the turbidity of the water coming out of the sedimentation trough. Perform sludge disposal as required with drain valves or scraper. And the cleaning maintenance is rinse, clean, and check the used parts 6 monthly. Dispose of disruptive materials or impactors that interfere with the performance of the tool 6 monthly. Check the chemical mixing pathway against possible blockage and disturbance other 6 monthly. This is our reference of all the materials. Okay, thank you. Wassalamualaikum warahmatullahi wabarakatuh.